Under this desert is a machine. It has no motor, no pump, and no electricity. But beneath the surface, something remarkable is happening. Water is moving through the darkness, powered almost entirely by gravity. And this was only one way ancient engineers learned to survive where water was scarce. Some moved water underground. Some built downward toward it. Others designed whole cities around it. And one civilization learned to turn dangerous desert floods into a resource. So how did they do it? Start in ancient Persia, where water could exist underground while communities struggled above it. Rain and snow entered the mountains, slowly feeding groundwater beneath the earth. The challenge was getting that water across kilometers of dry land. The answer sounds simple. Dig down, then dig sideways. The tunnel sloped just enough for water to travel naturally downhill. No engine had to lift it. No fuel had to push it. And hiding the channel underground gave the system another advantage. The desert sun had far less opportunity to evaporate the flowing water. Those strange holes stretching across the desert were part of the system too. They gave workers access for construction, ventilation, and maintenance underground. The system worked because it used the landscape itself as part of the machine. But in India, engineers solved the same problem in almost the opposite way.
Instead of bringing the water to people, they brought people down to the water. Stepwells turned access to groundwater into architecture. As the water level changed, people simply descended farther. That made changing groundwater levels visible and reachable. But watch what happens as you move deeper. Sunlight fades. Stone surrounds you. The atmosphere changes. These places could become more than infrastructure. They were also important social and architectural spaces. The engineering solved access. The architecture transformed the experience of heat. And then another civilization expanded water engineering from a structure to an entire city. Dholavira stood in a harsh landscape where managing seasonal water was essential. Its engineers didn't rely on one single source. They built a network designed to capture, guide, and store water. When water arrived, the city was prepared to intercept it. Stone reservoirs turned temporary flows into stored supply. Channels and drains made water management part of the urban design. That's the important idea. The city wasn't separate from its water system. The city itself was part of the water system. But storing scarce water is one challenge. Surviving too much of it at once is another. Petra rose from an arid landscape in what is now Jordan. Here, seasonal rain could be precious, and flash floods could be dangerous. Nabatean engineers couldn't simply hope the water behaved. They had to decide where it would go. Channels were carved directly into stone. Cisterns and reservoirs stored water after the rain disappeared. Diversion directs sudden floodwater. The water that threatened the city was also the water the city needed. The trick wasn't finding water, it was controlling when and where it moved. Now place all four systems beside each other. The qanat used gravity. The stepwell adapted access to changing water levels. Dholavira captured seasonal supply and stored it. Petra controlled sudden, dangerous flows. Different technologies, different civilizations, but one shared principle. They worked with the landscape instead of pretending the landscape wasn't there. That doesn't mean ancient engineering was somehow better at everything. Modern systems can treat contaminated water, serve huge cities, and monitor networks instantly. But many modern systems, something gravity doesn't. Continuous energy. Ancient engineers often reduced the work by letting terrain, gravity, and storage do part of it for them. Gravity doesn't lose power. Shade doesn't need a battery. A reservoir doesn't forget the rain. Which brings us back to the machine beneath the desert. Maybe the future isn't about copying the ancient world. Maybe it's about remembering what it understood. If ancient engineering surprises you, subscribe to Voltfolk. And tell me, which system would you trust with your city's water?